What do they say? Well, is my mic working? Yeah, yeah, there we go. What do they say? Better late than never. Sorry, we're a bit late. For those watching at home, we had some technical issues with audio, but we fixed it. Welcome to the ASV's May Astro Talk. Following tonight's presentation, we will be having supper. And is it raining still outside? Is it still cloudy? It's all clearing, is it? Cloudy. We probably won't open the observatory, but it would be nice if we had some clear weather. However, before we begin tonight's talk, in the spirit of reconciliation, the Astronomical Society of Victoria acknowledges the traditional custodians of country throughout Australia and their connections to the land, sea and community, and we pay our respect to the elders past and present and extend that respect to all Aboriginal Torres Strait Islander people today. Today, or tonight, we're going to hear a talk on Eclipse Chasers. Dr. Nick Lomb and Tony Stevenson will introduce their recently published book, Eclipse Chasers. They'll highlight some past total eclipses discussed in the book, the famous Einstein eclipse of 1922 and the eclipses of 1974 and 1976, in both of which the ASV was involved. As well, Tony will share her adventures at the April West Australia eclipse and point out the 4 upcoming eclipses in Australia. Dr. Tony Stevenson is an honorary history affiliate at the University of Sydney and has over 30 years experience working in museums and heritage sites in Australia and the UK. And Dr. Nick Lomb was the Powerhouse Museum Sydney Observatory astronomy curator for 30 years, but now lives in Melbourne. Melbourne's way better than Sydney. Normally we have less rain. And is a member of the ASV. He's an honorary professor at the University of Southern Queensland, as well as Eclipse Chasers. He is the author of the book Transit of Venus, 1631 to the present, and the annual Australasian Sky Guide. Welcome to the two of you. Nick will be up shortly. We're going to start with Tona. Are you there? You have to unmute yourself. Well, no, you've muted yourself again. Well,
thank you very much for that introduction. Yay.
All right.
And I do apologise. I think I was part of the technical problem tonight. But it's an absolute pleasure to be here with the Astronomical Society of Victoria. And I would like to also pay my respects, and also on behalf of Nick, to all First Nations people as the first astronomers in this land and many other lands across the globe. Our book, Eclipse Chasers, was primarily, the idea for it came about between Nick Lomb and myself. And it sort of started a long time ago when we were both looking through archival material. And I saw an image of an eclipse house on Gundawindi Racecourse. Now, being Melbourneites or Victorians, you'll know my only association with Gundawindi to that point had been a very famous racehorse. But seeing an eclipse house really stirred my curiosity. Nick also had a lot of curiosity about the past and what happened during eclipses, and we'll touch a little bit on that tonight. Next, please, Mark. Yes, so the book also was a great collaboration with other experts and authors. Dwayne Hummersher is well known, I know, to most of you as the author of First Astronomers. And Dwayne, we'd known for quite a long time and had discussed the idea for this book with him and about his research with First Nations people forming one of the early chapters in the book. And we were very fortunate to have Uncle Gilla, Michael Anderson, who some of you may also have heard to speak about First Astronomers book. And in this book, he actually tells stories of the Uline Nation that haven't been told before. So we were very honoured that he was willing to do that. Melissa Holbert and Jeff White are both astrophotographers, and they've provided many of the more contemporary images in this book. And also astronomers and educators. And Kirsten Banks is a up-and-coming astrophysicist. She's just about to hand in her PhD, and we really appreciated her talking about the upcoming eclipses and what she, as also a proud Wiradjuri woman, will be looking forward to, particularly in the 2028. I will say my thanks to CSIRO Publishing. Both Nick and I could not have asked for a better group to work with, and their guidance we would both like to acknowledge. Next, please. So we do live in fortunate times, and the number 400 seems to be pretty important in that the moon happens to be 1/400th of the size of the sun, and the distance is 400 times closer to the Earth. And so we are a very fortunate planet in this universe, where we get to be in the umbra of a total solar eclipse. So we get to be in that very narrow path of totality when the sky goes dark, and the animals and the plants and everything actually thinks it's actually we're going into nighttime. And then to see that amazing visual splendorous corona, and see the sun in all its glory. And so far, I don't think there's any other planet in that we found. We found lots of exoplanets that where if there was life, would have the opportunity for this amazing experience. The penumbra is an area where you can see partial eclipses, and I know many were looking for that in the recent eclipse a couple of weeks ago. I'm not sure in Melbourne that you had a clear sky or not, but I know in Sydney they did not. Still, it's interesting, but it's not the same. You don't get quite the drop in temperature. You don't get quite the change in light. And you certainly don't get that incredible visceral experience. And that's what we were trying to understand with this book. We had a few objectives, and one was to certainly research the past, but the other was to understand why people were, apart from the science, why they engaged in experiencing totality. Next, please. As I said, the book starts with the solar eclipses in First Nations traditions. And while there's no photographic evidence of past eclipses, the stories told by First Nations people, and some of these have been passed down through multiple generations, have led to the conclusion that there is science in their understanding of why eclipses occur. And you can see in this image, it's a contemporary image by David Boson from Mer Island. You can see the astronomer holding the sun and moon, an eclipse. And whether the sun was a woman and the moon a man varies. The idea of what was happening. Uncle Gilla talks about a union between male and female, how, forbidden love. These are amazing stories, and they do explain what was happening in a different way to Western science. Of course, they also explain why it's so rare. And Dwayne has spent quite a long time understanding how could these be either predicted, and we're not talking about long-term predictions here. We're not talking like Fred Espenak and NASA, putting out information about, years and or even centuries ahead and in the past. We're talking about predictions of something might happen in the next few days or the next few weeks. And this is explained really beautifully as being down to observation and the need to observe. which we've sort of lost that need in our contemporary society. So it's almost, it's very difficult to understand how that could be done, but it's beautifully explained in the book. Next, please. Now, something that is being explained in terms of recreating a mechanism is this Antikythera machine from the early Greeks, the ancient Greeks. And there is, in fact, a lot of physical evidence that they were able to predict eclipses. And, you know, this is a great example. It predicts the Saros cycle in the Greek region. So it's not trying to predict all the cycles or, you know, beyond that local region, but it is trying to in fact explain when the next eclipse and the eclipse after will occur, and you know, very convincingly. And you can see what was found in the sea, and a huge amount of research has gone into recreating how this mechanism actually worked. And it's actually been quite successfully done now. The reason it's called Antikythera is because of the area it comes from, but it is in fact a very early computer. And in the book, I also researched, you know, other cultures, and some people will say, of course, the Chinese 2,000 years ago were able to predict eclipses, and there are many other examples from the past where this was possible. The one I particularly like is the Emperor Hadrian from Rome, who was very enamored by total solar eclipses. And not long after he came to power, he minted a coin with his head on one side and a total solar eclipse on the other. And the British Museum has kindly let us use that image in the book. Next, please. Nick has done an amazing amount of research about the first series of total solar eclipses experienced in Australia, where Western science developed significantly over the period from 1857 to the early 20th century. And, you know, there's great stories and adventures told here, you know, also disappointments in Sydney for the weather, but they managed to take note of and measure how much light, how dark the sky went. Northern Queensland, we follow an incredible adventure by sea, some real hardships on the observing site, great anticipation and organisation, and then final disappointment. Flint Island, a bit more successful, and a bit more of a story where the government and Navy became involved. And it's often, as we see in history, where the government decides to support and then rally around and provide resources, that we see success occur, because there's the ability to be camps in different parts of the path of totality, which is really important, you know, to sort of make sure that you're not risking everything on one site. And Bruny Island, again, is a great story, and, you know, a lot of adventure. Again, Tasmania, couple of different sites, different experiences. And, you know, the thing is with this book, what we found was it was the environment, the landscape, the adventure, and some very unique Australian stories that made it quite a new piece of research and a new experience, I think, for us as researchers and writers, but also I hope for readers that you know, you'll go to some of these places in the future and see them a little differently than you would have. Vavau in Fiji. Again, a fabulous adventure and some great success on that expedition. Next, please. And now we go to 1922, and I'm just giving a little bit of a snippet of this particular eclipse. It was a very important eclipse, and I want to focus. Some of you may have heard me talk at the NACA conference primarily about the Lick Observatory expedition at Wallal Downs. I'd like to focus a little bit more on what happened at Gundawindi. In the book, we look at five significant stations. There were many other areas where people stopped and either did some scientific work or just went for the amazing pleasure of this eclipse. It was a much awaited eclipse because of the opportunity to prove Einstein's general theory of relativity. And it was also a time, it was after the First World War. 1919 impacted the world so significantly, and particularly Australia, where so many went overseas and lost their lives. And, you know, there's that great tie also with Britain, and that impacted the observatories in Australia because the British Greenwich particularly wanted Sydney Observatory and Melbourne Observatory to be involved in this eclipse. The Americans' Lick Observatory had an amazing international group of people over at Wallal Downs. But it was rather difficult for Melbourne Observatory because they didn't actually get the initial support that they had thought they would from the government. And you know, they really had to put forward many arguments. The government had approved for one of the members to go to Wallal, but they eventually put in some money for an expedition that joined the Sydney Observatory and the University of Sydney expeditions in Gundawindi. Now, this was only after a private sponsor had committed funds. Next, please. So the site of Gundawindi, you know, it was a site with a great view to the west. Of course, they didn't get the long totality that they had in Wallal Downs, but it was still significant. And the other thing that's very significant about this eclipse is that in June 1922, the Astronomical Society of Victoria was formed. And at that time, you know, in the Argus, there's that connection with the solar eclipse coming up. There's also the connection with the expedition members, particularly Charles Murfield, who was the first president of the ASV. James Baldwin was the organizer of the eclipse, and you can see him in this photograph in one of the 3 tents that they had set up on the Gundawindi racecourse. His son, Charles Murfield, I mentioned before, Zeus Murfield, his son, and Father Piggott, as well, as you can see in this photograph. And there were others. Their aims were not so much to prove the Einstein theory. They knew the restrictions of their equipment. They did borrow some equipment from Greenwich Observatory. Baldwin had been there a few months earlier and managed to borrow some equipment, but they knew that they just did not have what was needed. And that was probably a wise decision. Next, please. And this was a very popular eclipse. So on Gundawindi Racecourse, you had a lot of the public were there, and you know, wherever the eclipse was able to be seen, even in the partial phase, even in the penumbra, the population were very excited about this. And you can see in the Museums Victoria have a collection which has one of these viewing glasses. I would not recommend anyone using these particular viewing glasses because they're really film, as in, camera film, unexposed, and probably not a very good idea for use, but they were made in quantity, and they were used, as you can see, to raise funds for the building of the Great Ocean Road. And this is an expression, I think, of how the public was so engaged and encouraged to be engaged by the media. There were lots of talks, and it was a wonderful experience. This 1922 eclipse. The image in the middle is by Zeus Murfield, and it's the first image that appeared in the Argus newspaper a few days after 5 days after the eclipse itself. Next, please. And then, of course, Sydney Observatory, and William Ernest Cook was trying to, in fact, prove the Einstein theory, and he had brought up the astrographic telescope at very difficult thing to do. This is a quite a weighty telescope. At Sydney Observatory now, the Melbourne astrograph is on display, and it's a huge piece of kit. It's not like the ones that were at Lick that were actually designed to come apart like a Meccano set, and were quite lightweight materials. This was old technology now, the astrograph. Still good for taking great photographs, but unfortunately in this case, the drive mechanism that they'd really been forced to use on this occasion did not produce the results. In fact, it failed during totality, and they did not get the results that they wanted. However, like the others, they did get some great photographs and some information about the corona that was useful. Next, please. So the Lick Observatory had the equipment. You can see this Schaeberle telescope, very large, 12 meters high. This was not a new design, but what was a new design were two pairs of Einstein cameras, which were telescopes specifically designed and which had been to Tahiti 3 months earlier to photograph the sky prior to the eclipse. The area of the sky, the stars that would be seen behind the sun during totality, the day of the eclipse. A huge camp was set up, and the First Nations people, the Nangamata and Waran people, were instrumental in making this camp a success, helping build the tents, cart the telescopes, and provide carting water from the well 50 meters away, and dampening the white sails that they put around the instruments to cool them, and dampening down the ground with dampened soil and dampened branches. It was 31 degrees on the day, which I can relate to from my recent experience. And it was also windy, and First Nations people did a lot to help counteract the environmental effects. Next, please. And here we can see Elizabeth Campbell. So with the Lick Observatory, her husband William Campbell was the head astronomer, and both William and Elizabeth were very experienced eclipse scientists. And Elizabeth not only did a lot of the organizing of the eclipse venture, she also operated one of the telescopes and produced images of the corona. And I'm going to point out the other 4 women who were in this group all did scientific work. But it was a massive effort. There were over 30 people in this group, and they all had jobs to do. Next, please. And at Wallal, it's about 100 metres away, 150 metres away was Perth Observatory, and they had their own camp. They were trying to test Einstein's theory, but they also did not have the sort of equipment that Lick had. But what they had that turned out to be vital were the wireless signals. And I love this image because it shows, how the wireless operators were working, and they were receiving signals from Annapolis and Bordeaux. And you all know how crucial timing is in anything to do with astronomy. And particularly with total solar eclipses when you're trying to capture those few minutes of totality. Next, please. And here is the Lick Observatory party. And I want to point out John Hosking on the right, who had returned from the First World War. He was an engineer. He was working at Melbourne Observatory, and he was sent over to join the Lick Observatory party. Thanks. Next, please. And yes, they had success. So of all the parties, Lick Observatory was the one to prove that Einstein's general theory of relativity was in fact able to be proven, and that was now a done deal. And the reason was that they had 92 measured stars on their plate. And you can see this diagram on the right that William Campbell did. See, he's sort of drawn that deflection, and the degree of deflection was so close to Einstein's theory that Harold Spencer, who was the assistant astronomer at Greenwich, declared that after this they would not be disputing that theory or trying to test it specifically in the future solar eclipse expeditions. Next, please. I'm now going to pass on to Nick Lomb, if you'd like to share your screen, Nick.
My mic on again? Am I back? Am I back? Yeah? Yeah, all right. So now we're going to pass over to Nick Lomb. Nick, you can use this microphone or we can use that one. Which would you like to use?
I'll use this one.
Okay, when Nick's finished, we're going to go back to, yes, I can hear you perfectly. We're going to go back to Toner after you've finished your presentation.
That's correct.
Wonderful. Floor is yours.
Okay. Well, good evening all. It's nice to be here. Thank you very much, Toner, for your talk. Toner will come back later on to talk about the most recent eclipse seen from Northwest Cape in Western Australia. What I would like to tell you about is the Western Australian eclipse of 1974 and 1976. Toner talked about the eclipse of 1922, the famous Einstein eclipse. The following eclipse after the 1922 in Australia was the 1974 eclipse, closely followed by the 1976 eclipse. The reason I want to talk about them specifically is because, of course, some of you here will remember that eclipse, and also because the ASV was involved in those both eclipses. You can see the track of the 1974 eclipse, the central track of totality, actually missed the Australian mainland. But it just happened that a little bit of the southern part, the very southern extremity of Western Australia, was within the eclipse track. The 1976 eclipse track started in South Australia, went through Melbourne, Ballarat, and then through the south coast of New South Wales. So let's talk in a bit more detail about the 1974 eclipse. Most of the observers were in the three main places, Augusta, Windy Harbour and Walpole, trying to get as far away from the northern limit and as close to the central line as possible. The weather prospects were not good. Climate information, there was not that much climate information in this part of Western Australia, but from what little was known, when John Harris, the government astronomer in Western Australia, was asked the year before the eclipse what the prospects were, and he said the meteorological data at present available do not indicate any area which has a greater chance of clear skies at the time of the eclipse. In fact, they indicate that it's likely to be raining wherever you may be. So it wasn't that promising. There's a three-pronged sort of scientific research went on for the 74 eclipse. The first one was from CSIRO. They had a team set up at Walpole, led by Ron Giovanelli, who was the chief of the division of solar physics in the CSIRO. And they had a 0.4 meter reflecting telescope, which is pictured. They had a filter. And what they were trying to measure is the temperature, the electron temperature of the corona. Now, I'm sure you all know that the hydrogen is mainly, that the sun is mainly made of hydrogen. Hydrogen atoms are made of a proton, a relatively massive positive charge particle, and in a cloud around it is an electron, negative electron. The corona is extremely hot. The hydrogen is ionized, so protons and electrons move separately. So the CSIRO team was trying to measure the temperature of the electrons, and they did that by measuring wavelengths, the ratio of intensities at two wavelengths. Two is missing there. Ratio of intensities at two wavelengths of the K corona that's in a corona. The second prong was by Chuck Beckers from Sacramento Peak Observatory, who set up Windy Harbour. Even though Beckers came from the United States, Sacramento Peak Observatory, he did have an Australian connection because Ron Giovanelli had been his PhD supervisor. And he had a very interesting telescope, the Newkirk telescope, which you can see in the image. And there is Beckers giving a talk to school kids. But you can see on the image that the telescope does not move, does not track the sun. So instead, because they wanted to, the designers of the telescope wanted to do that for maximum stability. Instead, they moved the detector at the focal plane, so it's at the appropriate speed. And what he was trying to do is measure the density of electrons. So the CSIRO people were measuring the temperature of electrons. Beckers was trying to measure electron density. Unfortunately, it was cloudy for both the CSIRO people and for Beckers, but they tried. The third prong of the scientific research was from three United States laboratories from Los Alamos, University of Colorado, Sacramento Peak Observatory. And they were planning to fire, or they did send two rockets up, 30 seconds apart. The rockets were launched from a place north of Perth, just north of Perth. Now, if you recall from the map, the eclipse track on the ground was south of Perth, considerably south of Perth, but 30 kilometres up where the rocket's operational area was, where they were operating. the eclipse track had moved north, so the launch was from north of Perth. There were 2 rockets. Both had capsules with a payload of a high-resolution spectrograph and a camera. And what they were trying to do is to image the ultraviolet spectrum of the corona, which corona and the sun, which you cannot do from the ground. Unfortunately, one worked very nicely, because they knew that from telemetry. The other one didn't. The 2 capsules splashed down in the Indian Ocean, where one of them was recovered and one was not. And you can guess which one was recovered and which was not recovered. Of course, it was the one which didn't work was recovered and the other one was lost. So sadly, that experiment didn't work either. Now we come to, they were trying to measure the proton temperature of protons from the width of a hydrogen spectral line due to hydrogen. Now we come to the most interesting aspect of the 1974 eclipse, the eclipse flight. This was the first commercial eclipse flight organized by an American tourist agency, and the director of this was Horst Stengel, who's there on the picture. And it sort of tried to match the famous flight on the Concorde the year earlier, which, because the Concorde can travel at supersonic speeds, could actually keep up with the shadow moving, the shadow of the sun moving across the Earth. So the scientists on board the Concorde had 74 minutes of totality, which is just an unbelievably long time. As I said, it was organised Horst Stengel. His company, VIP Travel, was in California, actually quite near the JPL, Jet Propulsion Laboratories. And it was one of the JPL scientists suggested having the eclipse flight. It was basically because the central track of the eclipse missed the coastline. It was very difficult to send an expedition to. So what the suggestion was, they would send it to, would have organise an airline flight. Horst Stengel contacted ANZ Airlines. He had dealt with them in Australia before. ANZ Airlines contacted the ASV to find out if it's a good idea. The ASV said, yes, it is a good idea. And so ANZ went ahead. Fortunately, they had 2 aircraft that were certified to travel over water. Basically, it's because they had periscopic sextants in the cockpits, so they could navigate out of range of navigational devices. Of course, this was before GPS. Today, navigation is much easier. The captain of the flight was Captain Ken Morris, who happened to be a member of the ASV. And the aircraft flew at 950 kilometers per hour, which is less than the speed of the moon's shadow. So, of course, it couldn't keep up with the shadow, but the eclipse was longer from the aircraft and from the ground. And successful viewing took place, as you can see some of the photographs from Arthur Coombs. Arthur Coombs, as I'm sure many of you know him, was at that time the president of the ASV, and he took this very nice photograph of the diamond ring at the beginning of the eclipse, and then complete totality. And there is Arta, and there they are sort of beaming away, obviously very successful flight, and being very friendly with the young ladies who were stewardesses on the flight. Let's move to the 1976 eclipse, which I think some of you will remember. The weather prospects were, again, not the best. Prediction what the climate records indicated rainfall one day and two in Victoria, in southern Victoria, and that the sky would be covered by clouds, sort of quite a lot of the time, 3/4 of the time in southern Victoria, and in Ballarat rather, and sort of almost half the time, a bit more than half the time in Melbourne. A little bit better, prospects were a little bit better on the New South Wales south coast. The rainfalls one day in 3, and a little bit less cloudiness. Scientific research, CSIRO, this time it's the Division of Radiophysics, which did the research. They built specially built a radio telescope, 1 meter radio telescope, which you can see on the image. They set up at Stawell in Victoria. There's a bit of cloud during totality, but they did have useful results. They found the radio sun was just a little bit larger than the visual sun, but unusually the edge of the sun, instead of being darker as you get it in visually, it was actually brighter. People or physics staff from Wollongong University ordered a special filter to be able to look at the Fe14 emission line, which is highly ionized iron, which can only happen in the corona because it's extremely hot. They set up at Bombala. Now the filter didn't arrive, and unfortunately there was an airline handler strike at the time, and it was held up. The filter was held up at Melbourne Airport. In desperation, the people from Wollongong appealed to the head of the ACTU, Australian Council of Trade Unions, Bob Hawke, and then the filter was found and delivered to Bombala. Sadly, as we'll talk about again in a few seconds, it was cloudy in Bombala. Another experiment was to see if there's a bow shock due to the moon shadow. The moon shadow, it's cooler where the moon shadow falls, cooler, and it moves supersonically across the Earth's surface. So suggestion was made that it could create bow shocks as in a fast-moving boat in a river. And 2 people from South Australian Institute of Technology did find pressure variations, extremely small pressure variations, period of 23 minutes, which suggested that the shocks did exist. We know that it becomes darker during totality. Animals get confused, try to go to sleep, and then they have to wake up again. They get rather confused about the short night. But does it affect aquatic animals? And that was tested by a couple of groups. And one group took hourly samples of what's flowing in the stream or what's flowing in the Acheron River, and they found no change. Another group did find there was an increase in the flow for some aquatic animals, and I think we're talking about very small animals. So they found an increase, but only for some species. I mentioned Bombala. This was one of the main centres, or probably the main centre for the 1976 eclipse. It all started due to a letter to Sky and Telescope magazine by Roger Giller, who happened to be the eclipse coordinator for the New South Wales branch of the British Astronomical Association. And he wrote a letter to the magazine saying Bombala is the best place to observe the eclipse, and he's got access to a large property owned by a friend of his called Tregadar. And this really took off. Newspapers all said Bombala was the best place to watch the eclipse. All the service clubs in town became involved. Initially, it was only meant to be the Lions Club, but because it started to look so huge, all the service clubs became involved. There was a festival of the eclipse planned. Now, one issue was how will people be able to look at the eclipse? But obviously it's dangerous to look directly at the sun with your unaided eye. But a guy called Roger Tuthill arrived from the States. He became a very well-known retailer of astronomical equipment later on. And he had aluminium-coated mylar filters, which he called solar screen with K. So that was a great idea. The service clubs bought $1,200 worth of solar screens, which was a lot of money in those days, which would have been fine, except there were questions in the New South Wales Parliament and whether those screens are safe. And the Minister for Health asked for advice from the Department of Optometry, University of New South Wales, and the advice was those filters should not be used by untrained persons. So unfortunately there was heavy cloud and they expected 10,000 people for the festival. They only had 3,500, which meant they had a lot of food left over. So the clubs who were trying to raise money for charity didn't succeed probably lost money and didn't gain money. Nearby in the town of Merimbula, the Astronomical Society of Australia, the professional group of astronomers, arranged a meeting, and they called it a beach meeting. Their lectures were in the morning. It was a 3-day meeting. Lectures were in the morning on the beach on the blackboard as a visual aid. On the day of the eclipse, most of the people at the ASA meeting went over to Bombala and Tregadar, where there was a communal barbecue. So they didn't see it. But those people who stayed in Merimbula, of course, they saw it. So as always, you can regret what you do. Ballarat was also a major site. The local council prepared an observing site at the local airport. And visitors included this guy, Max Waldmeier, very well-known Swiss astronomer. And one of the reasons he was well-known is because he was the keeper of the Wolf sunspot number. As you all know, the sun shows an 11-year periodicity, and he kept the sunspot numbers. In those days, today you would download it through the internet. On those days, the only way you could get it by writing to him. And I became interested in analysing sunspot numbers around that time, possibly a year later, and I had to write to him to get them. And he arrived at the airport with the help of Graham Hood, who was the secretary of the secretary of the Ballarat Astronomical Society. The ABC TV also had their TV camera at the airport, and fortunately the clouds cleared before totality, and they had an excellent view of the eclipse. Let's move to Melbourne, and Melbourne had excessive warnings about the eclipse. Again, there were questions in Parliament about filters, and the Premier at the time, Rupert Hamer, said the safest thing is not to look at it, but wait until it's shown on television a little later. Health Commission of New South Wales, the Australian College of Ophthalmologists, the Optometrical Association all warned against looking at the eclipse. So people became petrified. I've heard just recently one family where they pulled down the blinds and they sheltered indoors from the special rays and dangerous rays that emanated from the sun during totality. Another family, they papered over the windows. They put newspaper up on the windows so no light could come in, no dangerous light could come in. So most people didn't see it, though it was fairly cloudy, patchy cloud. So some of them would have missed out anyway. But most people were just sheltering inside and watching on TV. There were posters on street corners warning eclipse today, newspaper inserts warning not to look. But a few serious observers saw it. For example, Barry Clark, whom I can see in the audience, saw it from here, from Melbourne Observatory, and he used the Troughton and Sims 8-inch telescope or 20 centimetre refractor, and it was Melbourne Observatory is almost totally deserted, Barry tells me. I'm not sure Barry Cleland saw it at Eclipse. I don't think he was there at the time. Another observer who did see it was Russ Cockman, and Russ saw it from his backyard. He was indoors. He thought it was hopeless. The sky was hopeless, so he stayed indoors watching on TV. But in fact, just around totality, he tried and he found he had an excellent view. And history repeats itself. We had the eclipse in Exmouth a few weeks ago. Again, there were excessive warnings. The Australian Radiation Protection and Nuclear Safety Agency said that people should not use eclipse glasses to look at the eclipse. And what I thought trumped it all, an ophthalmologist was quoted. This is in the article. This article here on the ABC from ABC Pilbara. He said. Well, he was basically saying, do not look at totality, don't use your unaided eye even to look at totality. He said the visible light is cut out by the solar eclipse, but ultraviolet light and infrared light still gets through, which I find very hard to imagine how infrared and UV would get through the moon. I don't think it's transparent, but that's what he said. And he also, at least that's what he was quoted as saying, and he also suggested the ultraviolet light can do a lot of damage. My understanding is that it's infrared light which does what's the short-term damage. UV light can do long-term damage. And with that, talking about 2023 eclipse, I hand over to Donna once again because she saw the eclipse and I didn't.
Thanks, Nick. And that's a great segue into well, I was very fortunate enough to experience on the 20th of April, having driven from Perth over 1,250 kilometres. It was for 60, what ended up being 62 seconds of totality. Some people were asking prior to the eclipse, how can that be worth it? And I can say without any doubt that it definitely was. I was very fortunate, of course, to travel with Melissa Holbert, my husband, Ron. Melissa has now experienced 10 total solar eclipses, and she has not had one disappointment. So she is an absolute must with any total solar eclipse that I go to in the future as well, because she does the research, and it's never a guarantee, of course, the research. But this was quite, the odds were good. The odds were very good for the weather for this eclipse. You know, we had, of course, you know, April in WA, you know, you could be very unlucky. There's some statistics put out, and, you know, we look at the weather very carefully. But the chance of being rain in April was only, you know, a bit over 1 day of rain, the mean number of days, and, you know, cloud cover with an average of 25% or less, 14.6 days. Total cloud cover, or more than 75% cloud cover, was 6.5 days. You know, the chances of reasonable weather were very high. As you can see, the path of totality was very narrow, and, you know, around 250 kilometres can be the path of totality. This one was only 40 kilometres wide. So there wasn't really an option to do what we had done in when we were at Port Douglas in 2012 and make a decision at 2 a.m. and say, we're not going to stick by the coast, we're going to go up into the mountains because we know we'll have a better chance there. There was really no option for that. We knew we would have a set site, and that's where we'd have to be. The site we chose was right near Lomb Solar Observatory, and you can see on this diagram the path of totality, and that was in fact, it was nearer to the red line, that center line of totality, than Lomb Solar Observatory. It was halfway between. So it was very, very close to the absolute maximum. So we got a bit more than the 60 seconds of totality. It was to start in the morning. We were actually staying down at Coral Bay, which was around 160 kilometres away. So it meant a 5 a.m. start, which was fine. But the days before, we'd gone up and we'd checked out the site. We had other options if we thought that site wasn't going to be good, but we could see what the preparation that they were doing on that site. And the preparation actually reminded me a lot of the 1922 eclipse. Next, please. And you can see in this image, this was our site. You can see Melissa there on the left with her camera and filter, another movie camera here in the front, and me behind with my camera. And you can see this is it was probably about half full at this stage. There are up to around 2,000 people on this site, but notice the red earth, and you can see the mountain in the background. Right in front of us was the sea. And what they'd actually done is they'd actually graded the ground, and they'd put this heavy red earth. And then the day before, they'd actually dampened down the ground. So, all when I could see what was happening, it really made me think that back to Wallal and the 1922 eclipse and what was happening there. The weather was hot, and it was predicted to be around 30 degrees on the day. So you can see we're well covered. During as the eclipse began, of course it takes quite, until you get, almost toward to totality, it's quite difficult to notice the change in temperature. But about 15 to 20 minutes before totality, we could really notice the change and the cooling of the atmosphere. Not as much as in some other places. I think it was around 4 degrees that we were able to get some data from other people about, but it was still quite noticeable. And when we arrived, it was very, very windy. And in fact, the wind was the thing that we were worried about the most. The days before the eclipse, having 62 seconds or 60 seconds of totality, we did do sort of tests and trials. So we kind of knew how we would act as we led up to totality. And again, I looked back to 1922 when they counted out the eclipse. And, that was how they practiced. They practiced the days before, and 10 minutes before, they'd count to when first contact to first contact, and we knew the time for that. There were people around us with screens with countdowns on it. I didn't want to be looking at a screen, actually. I wanted to either be looking with my glasses on, or as you can see on the right, we also had these fantastic binoculars with certified lenses, solar lenses, or using my camera. I didn't really want to be looking at a clock or my phone during that time. I'm not highly technological, as you can see tonight. I'm not someone that has a computer set up as some people did. However, that is also has another element of risk to it, as I did meet someone both at this eclipse and also heard someone who'd gone to Timor-Leste to view the eclipse at another talk, who said they had this amazing computerized setup and the whole thing failed. So it was very much a sort of rather manual operation in our little expedition camp. The thing that we did this practice beforehand, and my husband Ron he was the counter, so he would be calling out the time, and we actually had NASA right in front of us. So we had some really amazing people around us that he was able to use their very, very accurate countdown to do that, which was better than the calibration on his phone. And that worked very successfully, I think, for me, because could I have next, please? So I was able to take some photographs, and look, I'm sorry, I did have a layered effect happening here, which you can't see because of how I've had to do this tonight. But you can see we were able to see these great sun spots during the partial phase, and there were two quite obvious sun spots. There was another little group of 3 in a line right near there. We'd been watching these the day before, and we'd also been using a H alpha telescope to look for prominences. We knew there'd be great prominences. And this was a very unusual, rare hybrid eclipse. And so that means it started off as an annular eclipse and then became a total eclipse and then went back into an annular phase. Now, some of you may know how that might have impacted what we could see during totality. How were we able to see more prominences than before, or was the corona? Were we going to see more of the corona? I don't know enough to make any comment on that. I just know it was an amazing diamond ring and corona and prominence. Next, please. So this is one of my photos. You can't see the other layered ones, unfortunately, but you get an idea. This was an amazing diamond ring, both on entry of the moon, through totality to its, and then the second diamond ring on its departure, which is what you're looking at in this image. And you can see the prominences. Where the diamond ring is, there was actually an amazing archway prominence that you can see in some other images that I took, that but it was quite spectacular. And 62 seconds is so fast that I'd simply pointed my camera, and thankfully the wind had abated. And for those who have seen many eclipses, this is quite a common phenomenon. When we had arrived at the site, as I said, we were concerned about the wind, and the wind actually knocked over one of my smaller tripods that had a small camera on it that I was planning to use, and I had to come up with some other ways of securing that. But you could definitely see the camera shake, and it was quite a concern. Of course, I had a remote operation for the shutter, but just before totality, the wind completely died down, and we got all of those amazing effects of the the change in light, going from quite a warm glow to quite that ashen hue. It didn't become totally dark. I guess because of the width of the line of the umbra, it was always like a twilight effect. I also found it hard to find the time to look for the planets and the stars. I saw Venus and Jupiter, which are pretty obvious to see, but I just didn't have time to look for Mercury, which was also there, and Saturn was right over to the side. But and I did not have time to look for stars. But I did see a wonderful photograph from a 16-year-old Victorian young man with his father, and he had managed to take some great photographs with the planets in there, but not the stars. As I said, NASA were right in front of us. They were doing a live stream. Adriana Massatoni did a fantastic live stream with a really great unscripted narrative and quite informal narrative that went with it. As you might predict, when first contact happens, everyone kind of claps and, it's happening. But these diamond rings, I think the first one, people were just so in awe of it that, you got almost a sort of shock feel. But the second one, when everyone knew that's it, the glasses back on, and a huge clap and roar from the crowd. So I'm looking forward to the next ones now, which will be longer than 62 seconds of totality in Australia. And you saw at the beginning of this presentation, the sort of almost series of 5 that happened in Australia from the late 19th century through to the early 20th century. If I can now go to the next slide, please, Mark. And, the book does cover the next, not only the eclipse I've just experienced, but the next 4 ones after it. I'm not going to go into detail with the 2030 and 2037 and 2038 one, but I would like to sort of switch a little bit to the 2028 one, which is in my next slide, please. So this will be an amazing eclipse. You know, we'll get a lovely long totality depending on where you are. The path of greatest totality will be up there in very northern Western Australia's Northern Territory. Jeff White, you know, did some research on good places to see this, as did Kirsten Banks, and that's in the book. But Devil's Marble seemed like an amazing place to be located, but certainly rural New South Wales and Sydney. Next, please, Mark. And Jeff has done this artwork to show, you know, maybe we can say Sydney will be fine for this eclipse. Not sure. I think I'll be going into rural New South Wales, looking at the weather predictions. But hey, it'll look amazing over the Opera House and Harbour Bridge in Sydney Harbour if the weather pays out. Next, please. And this is a long eclipse, so, you know, there'll be over 3 minutes, and there will be time to look for some of the objects that Jeff has done this stellarium image for us. So you can see, you know, it will be a great opportunity to look at those planets. And, you know, this, again, it's a nice high eclipse, so, you know, that has some advantages. And in terms of what you can see, and it will be quite a spectacular sight. That's all from me, and thank you very much for inviting us to speak tonight. I started at the beginning of this talk about what makes an eclipse chaser and why do we still chase eclipses. I'm not doing any science, but I'm definitely passionate about the history and the scientific work that's happened over the years, and some of those amazing stories. You heard, you know, the sort of trials and tribulations, the successes, the disasters and disappointments from Nick tonight. Some of those he related, and there's always a sense of anticipation and curiosity, and every eclipse is different. You know, was the diamond ring more spectacular at the eclipse I've just been to than the one before? I've been comparing some photos. I do think it was, but I know there were some fantastic features of the 2012 eclipse. I'll certainly be preparing for the 2028 eclipse and looking very closely at the weather and great places to be. Thank you very much. Mark, next one, please. Hello. Hello.
I believe the book is available at all. Is it online only, or is it bookstores as well?
Oh, it's available in bookstores and online as well. It takes about...
Yes, bookstores. There we go. Very easy to get a hold of. There you go. $40 is the regular retail price, but it is available cheaper, well worth purchasing. A very, very good book. And if you're an AC member and you see Nick running around somewhere, you can probably get him to sign it for you. Yeah. But once again, thank you very much, everyone, for being here. Thank you to our two speakers for tonight. Next month, we have Hans, the new president of the Astronomical Society of South Australia, coming over. And he emailed me today. And if you bear with me 1 second, I'll tell you what he's talking about. He's going to be talking what's in a name? Kepler, Fraunhofer, and Bernhard Schmidt, marginal remarks on astronomy made in Germany. So he'll be talking about German astronomers next month. Also wanted to say a very big thank you to Bob. Bob, who's been our supper man for many, many years, who has decided it's time to step down from doing supper. And that means we're looking for somebody to take over providing supper at the monthly meetings. So if there's an ASV member out there who's willing to take up Bob's spot, it'd be wonderful if you could let us know and give us a hand with that. But Bob, thank you very much for providing supper. And one last big thank you to Lee for working through all those issues tonight. It might have taken us an hour or so to get it sorted, but we did get it sorted. So thanks for that. Wouldn't have been able to do these without you. We've got a Sea Lake members event only for the King's birthday weekend. I'm not sure how much accommodation is left. I don't think there's much left at all, actually. So if you are an ASV member and you're looking to come and hang out with the astrophotographers and visual astronomers, there'll be a whole heap of people up at Sea Lake over the King's birthday weekend. Tom Fowler and Alex Cherney will be teaching members how to do nightscape imaging, art silo imaging with the Milky Way in the background, and sunset imaging out at Lake Tyrrell. So if you want to grab some accommodation, the information's all on the website, and bookings are open also for the Sea Lake Astrofest in November as well. So thank you. Thank you, everybody, for joining us tonight, and we will see you next month.